Bismillah ar-Rahman ar-Rahim. We'll start now. We'll start talking about this section, which is implicit differentiation. What we mean by implicit differentiation, or where we need this implicit differentiation? Usually we have the functions defined as y equal sine x squared plus cosine ax, something like this. So I have y as a function of x. This is, we don't need, I mean, we can work it out like before, like 3.4. However, if I have a relation like this, if I have a relation x cubed, for example, plus y cubed plus sine xy equal e to the power y square minus 3x, something like this, where I cannot write y as a function of x. But it will be very complicated to write y as a function of x. Such relations, if I want to find dy by dx, what shall I do? Look at this. This is the guidelines for implicit differentiation. My first step, I differentiate both sides, since I have two sides, left side and right side, right hand side, the left hand side. Differentiate both sides with respect to x. And then I solve for dy over dx by collecting all terms involving dy over dx in one side, and I put the others in the other side and just divide to find dy over dx. So my first step, this is the most important step, which is I differentiate both sides with respect to x. Let me tell you about this, the differentiation, because I can have the functions in terms of, I have function of x, or I have functions of, functions of y. Okay. Now, if I have function of x and I want to differentiate with respect to x, so the variables agree. This is, we can do it like before. It will be derivative of x cubed equal 3x squared. Actually, it should be like dx over dx. I have the derivative of the things inside, which is x. So I have dx over dx, which is 1. Because of that, we don't write it. Okay. However, if I want to differentiate with respect to x, I want to differentiate y cubed. Now, when I differentiate this relation with respect to x, maybe I will go to x cubed, sometimes a function of x, function of y, combination. We need to deal with this. So if I see y cubed, I want to differentiate y cubed, what shall I do? Do the same. It will be 3y squared, but I need what? dy over dx. So that will be actually 3y squared y prime. 3y squared y prime. Y prime is dy over dx. That's mainly the idea. Now let us go to the calculations. Okay. I have this x squared plus y squared equal 25. I want to find dy by dx. By the way, this is, you can write it y equal, but it will be plus or minus. It will need some calculation. Now, what I will do, my first step, differentiate with respect to x. Yeah, if I do that, what's the derivative of x squared? It will be 2x. I don't need dx over dx, which is 1, so I don't need it. Now this is plus. Now, when it comes to y squared, that will be 2y, y prime. 2y, y prime, because I need to find the derivative of the things inside, which is y. I need dy over dx, which is y prime, equals, the derivative of 25 is what? 0. So now I solve for y prime, so y prime will be what? Minus 2x over 2y. In other words, minus x over y. Minus x over y. That's it. We find y prime. Now, second part. Like before, sometimes he asks you find the equation with tangent line to this curve or this circle at this point. So this is the point of tangency. I have to find the equation. I have a point. I need the slope. How to find the slope? It's f prime But be careful here. It's y prime or f prime, who cares? Y prime, but now, since I'm writing y prime in terms of x and y, so at x equals 3 and y equals 4. And now we do the calculation. So the slope of the tangent will be y prime at x equals 3, y equals 4. And that equals what? Minus 3 over 4. So that is the slope. So what will be the equation? I have the point. I have the slope. We can find the equation. Y minus 4 minus 3 over 4, x minus 3. So that implies what? Multiply by 4. I have 4y minus 16 equal minus 3x plus 9. So I have 4y plus 3x. I took everything to this side. Minus 25 equals 0. This is one way to write the equation. Yeah, it depends on the way the answers. I mean the way you have the answers. Sometimes you can write it y equal, or you can write it this way. It's up to you. Another problem. Find dy over dx for this function. I will do the same. So differentiate with respect to x. So the derivative of this, 3y squared times y prime. What's the derivative of this? 2y times y prime. Derivative of this, minus 5y prime. So every time I have y, I need y prime. This one, no need for. That will be minus 2x equals to 0. Now I solve for y prime. So you combine the things with y prime, which is 3y squared plus 2y minus 5. All of this times y prime. This thing, they take it to the other side. So it will be y prime 2x over it will be 2x over 3y squared plus 2y minus 5. That will be my answer. That will be y prime, or dy over dx. More problems. Yeah, let me do number 1. Easy one. X squared plus y squared. In all of these problems, I will do this. Differentiate with respect to x. Okay, so the first one. I have 2x plus 2y. Y prime equals 0. So y prime equal minus 2x over, so minus x over y. That will be solution of the first one. Second one. Second one, you need to be careful in the calculation. I have what here? I have product of two functions, x squared times y squared. So we'll do the product rule. But when I differentiate y, I need y prime. Okay. So what's the derivative of the first? 2x times the second plus the first derivative of the second. What's the derivative of y squared? It will be 2y y prime plus what's the derivative of 2y? 2y prime. Derivative of 4x, 4, that equal to 0. Now we need to solve for y prime. Combine the things in y prime. I have this and this. So I have y prime times what? 2x squared y plus 2. Yeah, plus 2. That should equal to these things that take it to the other side. Minus 4 minus 2xy squared. So y prime will be minus 4 minus 2xy squared over 2x squared y plus 2. You notice that I can take two common factors from the numerator and the denominator. So I divide by 2, numerator and denominator. So I have minus 2 minus xy squared over x square y plus 1. Plus 1. Okay. Double check here. 2y prime, that's 2y prime plus 4. So I combine the ones with y prime. 2x square y plus 2 times y prime equal minus 4 minus 2xy prime. I divide this by this. I took 2 common factor. And I cancel 2 from both numerator and the denominator. That will be the answer. Number 3. Y to the power 5. I think it needs more space. So let me go here. How to differentiate this? That will be 5 y to the power 4 y prime. This one, product of two functions. The first derivative of the first, 2x. Yeah, just you need to follow the steps. 2x times y cubed plus x square, derivative of the y cubed, which is 3y square y prime. That should equal to what? 1 was the derivative of 1, 0. Now I have product of two functions again. That will be y prime e to the power x square plus y, derivative of e to the power x square. I need a chair rule here. Ax square times derivative of x square, which is 2x. Okay. Now combine the ones in y prime in one side, the ones with no y prime in the other side. So I have 5 y to the power 4. This is with y prime. Also this one with y prime plus 3x square y square. And this is y prime in the other side, so I return it back. That will be minus e to the power x. All of this times y prime equals. What will be the other side? I need to take, so I'm taking this side, I'll take this the other side. So I have what? 2xy. Yeah. 2xy e to the power x. And if I took this the other side, minus 2xy cubed. So what will be y prime? It will be this 2xy ax minus 2xy cubed over 5 y to the power 4 plus 3x square y square minus e to the power x. Yeah. What I did, differentiate, combine the things in y with y prime on one side, and solve for y prime. Yeah. This is 2xy cubed plus x square 3y square y prime. This will be y prime e to the power x square. Yeah. Plus 2xy e to the power x square. Sorry, this is x square. Yeah, I have the square here. So this is 2xy. Yeah. So the other side will be 5y to the power 4 plus 3x square y square minus e to the power x square. Yeah, sorry, this is x squared also. Square, forget the square. Yeah, so this is x square equal to xy e to the power x square minus 2x y cubed. So I divide by that and that's it. Okay. Now the fourth one. Okay. What is that? I have sine of function. So that will be cosine of the function, which is x squared y, times derivative of this. That will be what? 2xy plus x squared, derivative of y, which is y prime, minus sine x equals 0. Okay, so let me open the parentheses. I have what? Be careful. 2xy cosine x square y plus x square cosine x square y times y prime minus sine x equals 0. So combine the things now with y prime on one side, the other is on the other side. So I have x square cosine x square y times y prime. That's the only things with y prime. Take the others to the other side. Sine x minus 2xy cosine x square y. So it will be y prime. It will be sine x minus 2xy cosine x square y. Yeah. Cosine x square y over this, which is x square cosine x square y. Yeah, I think the idea is very clear. Do more problems, okay? And then I will go to the odd examples. Okay. Find y prime if sine x plus y equal u square cosine x. The same thing. Differentiate with respect to x. So what is this? I have cosine x plus y, derivative of this, which is 1 plus y prime. That equals to what? Now we have product of two functions. Derivative of the first, 2y, y prime times cosine x. Then derivative, then the second time derivative, the first time derivative of the second, which is minus sine x, which is minus sine x. Okay. Yeah, now we need to combine the things with y prime. Let me open this. That will be cosine x plus y plus cosine x plus y times y prime equal to y prime cosine x minus y square sine x. Now the things with y prime, I have what? Cosine x plus y minus 2y cosine x equals, I take this to the other side, minus cosine x plus y minus y square sine x. So y prime will be this. Over. Yeah, you can write in a different way. You can divide by minus. You can do the things you want. Okay, let me go to all the exams questions related to this, which is very simple. Okay, now I have this. What's my first step? Differentiate with respect to x. Okay, so here I have what? Product of two functions. So be careful. Y prime, first derivative of the first times the second plus y derivative of the second. This is cosine of u. So it will be minus sine of u derivative of u, which is 2 plus. Be careful here. I have something square. This is, you can look of it, sine of y all square. You can think of it this way. So it will be 2 sine of y to the power 1, derivative of this, cosine y, and the derivative of this, which is y prime. Okay. Now, the things with y prime, take it in one side. This is the power 1, I don't need. Okay. So what I have y prime. This is cosine 2x. And yeah, by the way, this is equals to, this is pi. What's the derivative of pi? is 0. Okay, so I have this plus 2 sine y cosine y. This thing, I take it to the other side. So that will be 2y sine 2x. 2y sine 2x. Okay, so y prime equals what? 2y sine 2x over cosine 2x. You need to notice one thing. Now, what is this? This is sine 2y, sine double angle, 2 sine cosine. Okay. So this is plus sine 2y. That is the answer. Yeah, 2y sine 2x over cosine 2x plus sine 2y. More problems. Differentiate with respect to x. Differentiate with respect to x. That will be what? This is product of two functions. Derivative of the first, 2y, y prime times the second, plus the first derivative of 2x squared, which is 2x, plus 3y squared y prime equals minus 1 over x squared. What's different here, I need to find this when y equal minus 1. Notice, if y equal minus 1, because also I need x, huh? I don't need only y, I need x also. So if y equal minus 1, let me call this 1. So substitute in 1 to get 2, to get x, to get the value of x. What you will get? Substitute minus 1. I have minus 1 square, 1 minus 1. That will be 0. 0 plus minus 1 cubed, which is minus 1, equals 1 over x. So it will be x will be minus 1. X equal minus 1. So I have y equal minus 1 and x equal minus 1. I plug it here. So substitute. Let me call this 2. X equal minus 1, y equal minus 1 into to get what? To get y prime. So I have what? Here I have minus 2 y prime, because this is minus 1. Minus 1 squared is 1, so it's minus 2, plus, if we plug minus 1 here, I have 0, plus 0. Here I have what? Plus 3 y prime equals to minus 1 over minus 1 squared equal to minus 1. What is this? This is y prime equals to minus 1, and that will be minus. Okay. Yeah. If x is equal to tan 2y, find dy by dx. Okay. Differentiate with respect to x. Differentiate with respect to x. What's the derivative of this? This is 1 equal. What's the derivative of cotan? It will be minus cosecant squared 2y times the derivative of this, which is 2y prime. I'm looking for y prime. That means y prime will be minus 1 over 2 cosecant squared 2y. 1 over cosecant squared, that will be sine squared 2y, which is this answer. Easy one. If I do this, okay, I need to do now differentiate with respect to x, but it's a little bit lengthy. I have here chain rule. I have 3 x squared. Yeah, I need to think more space. I have 3 x squared plus y squared all square times derivative of this, which is 2x plus 2y, y prime. That equals 2. Derivative. Now I have product rule here. That will be 8 times y. I do 8x is the first function and y is the other function. Plus 8 plus 8x y prime. Now I try to combine the y prime in one side and the other in the other side. Or first I will open this parenthesis. So I have 6x. I have 6 x times this plus 6y times this times y prime equal 8y plus 8x y prime. Now combine the things with y prime. I have what? 6y. This one I took it to this side minus 8x equal 8y minus 6x. Okay. Very clear, I can divide by 2. So let me do that. Y prime and divide at the same time. Can divide by 2, so I have 4y minus 3x x squared plus y square over, can I divide by 2 also? I can start with this one to make it the same format. Minus 4x plus 3y. So this will be my answer. Yeah, the same answer. G of x. Now he put g of x. Okay. So differentiate with respect to x. Differentiate with respect to x. Okay. So the derivative, this is like y. That will be g prime of x. Here I have product of two functions. Derivative of the first, which is 1 times the second, plus x. Derivative of this, I need the chain rule. Cosine g of x times derivative of this, which is g prime of x. That should equal to x. That should be equal to x. So I need to find g prime at 0. G prime at 0. So it means what? I let x equal 0, see what will happen. I have g prime at 0 plus sine g at 0 plus all of this is 0 because x is 0. I have 0 times function times value times value. So I have 0. And this one is also 0. Now what is g at 0? G at 0 it's theta. So I have g prime at 0 plus sine theta equals 0. In other words, g prime at 0 is minus sine theta. What theta is? Okay. Suppose y is this for x and y functions of t. They are functions of t. If dx over dt equals 3, then he wants the value of dy over dt. Okay, so in this case, I will differentiate with respect to t, because you have the things in this t. Actually, we'll do these things in 3 points. Okay, but we can't do it here now. I differentiate and make the derivative with respect to t. So what will be the derivative of y? It will be dy over dt. And this one, you can think of it as 2x plus 1 to the power half. That will make it easier. So I have something to the power half. That will be half 2x plus 1 to the power minus half times derivative of this. Don't forget, I need the derivative in terms of t. Because of that, that will be 2 dx by dt. Since I'm doing the derivative with respect to t, not with respect to x. Done. So now, what I want to find, dy over dt. Dy over dt, I have x equal 4, and dx over dt equal 3. So that I have half x equal 4. I have what? 4. 9 to the power minus half. That will be 1 over 3, square root of 9. 1 over times 2, sorry, times 2 times this, which is 3, huh? Said this one is, give us, this is 3. So the answer is what? This cancelled, I'm getting 1. So this will be my answer. Okay, the same thing. But this is a little bit lengthy. He said what? Let x be the differentiable function of t. I have dx over dt not equal to 0. And I have this relation. He wants how many points? I have dx over dt equal dy over dt. So he wants to relate dx by dt by dy over dt. Actually, this is as I said before. It will be dealt in more details. Dealt with in more details in section 3.1. Okay. Now we differentiate this with respect to t. Differentiate with respect to t. So I have what? 2x. Don't forget, I need dx by dt. Plus 2y dy by dt. Minus 2 dx by dt. Derivative of minus 1 is 0. Derivative of constant is 0. Always it's 0. Okay. Now, I need to use this relation so that I have the things in terms of one variable only. Since, I mean the derivative at least. I know this is equal, or let me say, this with this. This is dx over dt. So I have 2x dx over dt plus y dx over dt minus 2 dx over dt, which is actually 2x plus y minus 2 times dx over dt. That should equal to 0. And he told me this not equal to 0. So that means 2x plus y minus 2 equal to 0. In other words, y equal to minus 2x. I get y. And also I have this relation between x and y. So what I will do, I'll plug this for this one, substitute in 1 to get what? X square, y square, which is 2 minus 2x square minus 2x. That should equal to minus 1. I have equation one variable. Let me solve for x. So what I will get? I'll get x square. This is perfect square. So I have 4 minus 8x plus 4x square minus 2x equals to minus 1. So I have 5x square, 5x square minus 10x plus 5. Yeah, take minus 1 the other side, plus 5 equals 0. Divide by 5, have x square minus 2x plus 1, which is x minus 1 all square, equal to 0. So I have x equal 1. If x equal 1, y will be what? Substitute it here. Y equals 0. So how many points we have? 1 point only. And that is 1 and 0. So this will be my answer. If x equals sine y over sine 1 plus y. You want dy over dx. Okay, differentiate with respect to x. What the derivative with respect to x? In that one, you want the derivative with respect to t, huh? Because that differentiate with respect to t. So I have this one. I have quotient rule here. I have cosine y times y prime times the denominator minus the numerator it's clear. sine y times the derivative of this, which is cosine 1 plus y, derivative of this one, which is y prime, all over all square. Okay, so I have what? I have sine square 1 plus y equals y prime times cosine y, sine 1 plus y, minus sine y, cosine 1 plus y. Be careful. You need to remember this formula. Sine A minus B, it will be sine A cosine B minus cosine A sine B. If you look at that, I can consider this is A and this is B. So I have sine A cosine B minus this is B sine B cosine A, and this is A. So this one is the difference of two angles. I need the formula for the difference of two angles. So that will be y prime sine A, which is 1 plus y, minus B. And this is sine square 1 plus y. So this is what? This is, let me write it here. That is y prime sine 1. So y prime will be sine square 1 plus y over sine 1. That's it. Okay. More problems. I think two more problems. Okay. Yeah. Now, what we have here? We have a function y equal f of x, and I have this relation, which is related also to the derivative. I have f at 0 equal 1. That means y at 0 equal 1. And he want y double prime at 0 equals what? Yeah. I have x, y double prime, plus y prime, plus xy equals 0. I think you need to say that the function is differentiable everywhere. Okay. Now we'll differentiate. Differentiate with respect to x. Get what? This is product of two functions. Derivative of the first one, y double prime, plus x, y triple prime, plus, what's the derivative of this? Derivative of y prime, which is y double prime. Have product of two functions. Derivative of the first, plus y prime. Yeah. No. Derivative of the first one times y. So this is plus y plus xy prime. That should equal to 0. So what I will do now, substitute at 0. To get what? I have y double prime at 0. Here I have what? 0, because the x is 0. So that plus 0, plus y double prime at 0, plus y prime y at 0. Y at 0, I know it, it's 1. Huh? And this is 0 times something, 0 equals 0. And this is equal to 1. So I have 2 y double prime at 0 equals minus 1. So y double prime at 0 equals minus half. That will be the answer. Okay, let me finish by this question. You want us to use the Leibniz notation. Okay. First, let me try to get if x equals 0, if x equals 0, u equal to what, and y equals to what. Let me call this equation. This is 1, and this is 2. I have x equals 0. Substitute in 1. Substitute in 1. In 2, I mean, in 2. To get what? I have 0 equal u minus 1 e to the power u. This is never 0. So I have u equals 1. So now substitute in 1. So I have 1. I have u is equal to 1. 1 equal e to the power y cube plus 2y. Don't forget, 1 is what? E to the power 0. So I can compare it now or take ln of both sides. That give you what? Y cubed plus 2y equals 0. So I'm getting what? Take y squared plus 2 equals 0. This is never 0. Y squared plus 2 cannot be 0. Actually, it should be greater than or equal to 2. That implies y equal 0. So I get now the values, if x equals 0. Now let's go back to the derivative. Let's go back to the derivative. I know that dy by dx is dy by du times du by dx. Du by dx. Okay, this is the relation which I will use. So find dy by du. I have this. So I have u as a function of y. So I need the implicit. What you will get. Now differentiate with respect to y. Let's have u equal this. Let me write it. Here, differentiate with respect to u. Differentiate with respect to u because I need to find dy in terms of du. So do the derivative with respect to u. So I have 1 equal e y cubed plus 2y. Don't forget, times derivative of this with respect to u. So I have 3y squared. I need dy by du. Plus, what's the derivative of this? 2 dy by du. So if we do the calculation, dy by du, now let me do it in steps. Don't rush it. Have 1 equal e y cubed plus 2y. I have 3y squared plus 2 times dy over du. So dy by du will be equal 1 over all of this, which is e y cubed plus 2y times 3y squared plus 2. Are we done? Not yet. Now we need to find what? Du by dx using this. Okay, I have x equal u minus 1 e to the power u. Find du by dx. Implicit and differentiate with respect to x. What will get? We'll get 1 equal here a product of two functions. Derivative of the first du over dx times eu plus the first derivative of the second eu times du by dx. So that equal du by dx eu plus u eu minus eu. So that will be u eu du by dx. So du by dx will be equal 1 over u e to the power u. Okay, now I need to combine everything. I have dy over dx is this. I need to combine it now. dy by dx by dx That will be dy by du times du by dx. dy is 1 over e u cubed plus 2y, 3y squared plus 2. Check. Yeah, this is dy by du. du by dx is 1 over u e to the power u. Now, I need to find dy by dx at x equals 0, and if x equals 0, u equal 1, and y equals 0. So I substitute y equal 0 and u equal 1. So that will be what? 1 over e to the power 0. 3 times 0 plus 2, that will be 2 times 1 over, this is 1 times e. So the e to the power 0 is 1. So I have 1 over 2e. And that is my answer. Okay. Yeah, I think I will stop the recording. Yeah. Let me stop the recording. Thank you.